Okay, should I go ahead and start now, or are we waiting?
Yeah, I have a recorder.
Okay, perfect. You are sharing the screen, right?
Yeah, it's my screen.
Okay, okay. You can minimize that window, I guess. That pop-up.
Oh, it's fine.
Okay. So I think it's just few folks here. So yeah, I'll start with the topic. So today we're going to discuss about using GCP BigQuery for RDBMS business solution, like how in CVS we are using BigQuery. Like previously we were using Teradata, and now we migrated from Teradata on-prem to GCP BigQuery. So I'm gonna walk through like high level what is BigQuery architecture and how it compares with traditional data warehouses, and what all features in BigQuery we are currently using, and the other use cases that BigQuery support as well, which we haven't tested yet, but definitely something that is of area of interest for everyone. Uh, so compared to BigQuery with traditional warehouses, so currently, for example, Teradata is what we are using at CVS, and though it is considered as a OLAP data warehouse, which supports massive volume of data. It has this parallelism architecture where the optimizer converts your query and runs in parallel, right? And Teradata also supports the integration with multiple BI tools, and currently on-prem we are doing complex analytics as well. Uh, and the data access is being done at the row level in Teradata, right? So even apart from all these features available, we are still running into multiple issues for data engineers, uh, especially because of the massive increase in the volume of data at CVS. We always run into data quality issues or complex analytics that we want to perform on-prem. We were not able to do it. So I'm just listing out some of the challenges that we are facing on-prem for the legacy warehouses, especially like Teradata or SQL Server, where the currently Teradata is not scalable. Like if the table size is huge, no matter what optimization you do, we always run into some bottlenecks, mainly because of the performance issues, or maybe the developer didn't give right primary indexes for the table, or he hasn't collected statistics in the table. So there are multiple reasons, but we always run into this computation issue where we don't have enough resources to run our analytical query. Right. Similarly, data lineage. As a data engineer, for us to understand why some data is causing an issue, or why there was some issue in the data pipeline, understanding the data lineage is very important. If you can understand where this specific column or specific data is coming from, we can fix the root origin of the source, so that all the downstream applications do not have this issue going forward. So without data lineage, it's impossible. I mean, it will be very time consuming for data engineer to understand the source data issue and fix it. So that is one of the major issue that we are facing in on-prem Teradata as of now. Uh, and coming to data governance, currently data is everywhere, right? Everyone is trying to create their own data silos. There is no proper data governance to understand, like for a specific table, if I want to understand like what is it, who is creating it, or how frequently is being refreshed. So such kind of information is not being captured on on-prem. And of course, we have the data quality issues as well that come, which disrupt our production pipelines now and then. Uh, uh, these data quality checks, which even though the developer sometimes he covers most of the test cases, we always end up having to fix something in prod directly, right? And currently Teradata, we don't have a way to make it event driven application. So we had to depend on other applications which are not tightly integrated with Teradata. So that kind of a feature which cloud data warehouses provide is not available in on-prem, right? And real-time reporting. So we have multiple dashboards that were created on top of on-prem data warehouse like Teradata, but we can't really use a real-time analytics, even though Tableau supports it, even though Tableau is capable of doing it. Because of the massive volume of data, we can't really directly use real-time reporting, because real-time reporting, majority of the load falls on the database instead of Tableau. So we never really ended up using real-time reporting anywhere because of the performance issues of on-prem Teradata. And coming to job scheduling, it's always a pain because we have to work with multiple teams to schedule a job, trigger a maestro job, and schedule it. And if something goes wrong with the job scheduler, uh, it's difficult to track down the team and help them fix it. So these are some of the regular issues data engineer faces on-prem. So after migrating to cloud, I think most of these got resolved. I'll just walk through like how some of these challenges that were faced by data engineer were fixed on cloud. So I'll just walk through like how the BigQuery resolves it. I'll just go in step by step. Coming to the architecture, as we know, BigQuery separates compute and storage, unlike Teradata, where in BigQuery we have storage separated out from compute, and you can access storage separately using different APIs, right? So what this means for us is we can scale compute separately from storage. So there is no interdependency on the scaling factor. And BigQuery storage, this independency means we can directly stream the data from outside to BigQuery directly, BigQuery storage, without touching the compute. And this also enables us for BigQuery to optimize their tables in the backend without end user defining how to optimize the tables. So say today, if you create a table on big Teradata, the developer has to define how the table will be accessed, like what is the primary index columns or what are secondary index columns and all. But in BigQuery, we just don't bother about it. We just create those tables in BigQuery, and BigQuery does this backend encoding process so that the query, whatever we are trying to retrieve the data from, it gets optimized in the backend. Of course, you have to define the partition columns and clustering columns, but at least some of the dependency from the end developer is removed, and that optimization plan is being taken care by BigQuery in most of the cases. Right? And another big benefit of going to the cloud BigQuery is this is completely managed service. So we don't really see a downtime. It has a 99.9% SLA. And it's completely reliable compared to on-prem, where we have to go with multiple DBAs if Teradata is down, or if there is any job issue. Because the typical issues we face is the job that are being run by individual application team are being impacted for the actual production job. So there is no separation in the load. So if your application is taking much of compute resources, then the other team's jobs are getting affected because of there is no queue concept in Teradata, right? So this makes a Teradata admin to kill those application jobs immediately, so that the production EDW, ETL jobs run fine. So we have seen such scenarios, whereas in BigQuery, these issues were mitigated to a major extent. And also BigQuery also is doing this data replication in the backend, which the developer need not worry about. So this also makes sure that from DR point of view, data is replicated to multiple regions, which the developer need not worry about. And another use case is data is stored in a columnar format. That means whatever data you are accessing, you can access it at the column level instead of row level. That means you do not worry about bringing all the data from all the columns. You just need to query those specific columns that you are in need of. That will be very useful in terms of scanning the table point of view, right? So yeah, this is coming to the storage point of view, like what all benefits we have with BigQuery and the traditional drawbacks we see in traditional on-prem data warehouses like Teradata. And of course, coming to compute, we all know like the reason we go to cloud. It's the control on compute. So we don't need to worry about whether this job will fail or not in BigQuery. In most of the cases, the dynamic scaling that BigQuery provides resolves many of our issues that we see in on-prem, right? And also for table optimization, query optimization, BigQuery provides you the ability to partition your data or cluster the data for any efficient querying, right? And as I mentioned, BigQuery also supports creating those external tables. So if your data resides in GCS bucket, you can still use cloud storage as your storage layer, and you can create external table so that you can run your federated queries and keep your data stored in cloud storage or cloud SQL. And also it also supports Azure and all. We'll go through that later. But yeah, these are some of the benefits for BigQuery storage architecture. Because compute and storage are separated out, so one significant use case that we are currently using is querying the BigQuery storage directly using Python or Spark. Because we have our jobs on-prem Spark, so we did a lift and shift to cloud, and we still were able to use the same Spark job, but instead of pointing to HDFS, we are pointing to BigQuery here. So there is little code change needed when we are doing this switch. And it also gives us the ability to use different APIs to directly communicate with BigQuery. Similarly, for compute, I have a question. No, Jonathan. Currently, we haven't got a chance to use those nested fields. I know BigQuery supports it, but there might be a performance issue when we are using nested fields like JSON object data. But we currently don't have a use case as of now.
Also probably because of just the lift and the shift.
But yeah, that's a good catch. I think that's something. Even Teradata supports JSON data type. We actually tested a use case where we want a table which has the DDL changing every now and then. So we want to keep all those changing columns instead of adding a new column every time. We were in the plan of creating a JSON data type on Teradata, so that any new columns we add it to the JSON data type and access it via key value pair. But on Teradata, we faced some performance issues when using JSON data type. But BigQuery, we haven't seen that. But because Teradata is not scaling well, we didn't went with that JSON object data type approach.
Yeah, the performance. I'm sorry, Jonathan. Can you hear me in the room?
Yeah, I can hear you. Yes. Mighty.
Yeah, I'm not sure if Jonathan's question was recorded, but let's see. Do Michael explain a little bit like the scale issue? I think it's over 1 million. Then
right.
The query is not running very well.
Right. If it is more than 1 million records, where we have JSON object data type in Teradata, whenever I'm trying to parse a specific key in the JSON object, in Teradata we are getting this issue. It's not pretty scalable on Teradata. But on BigQuery, we never got a chance to test it. But at least on Teradata, we did test it, and it was failing. So we ended up using a different architecture of tracking this dynamically changing table structure, so that we take into account all those new columns every month.
I think it will worth to try, and also the benefit is that you will significantly
and coming to
reduce
the
your
BigQuery compute, as we all know, BigQuery is a managed service. So BigQuery provides the slots based on the query load. So it's pretty much scalable, and it's also federated. That means we can query the table, whether it is in BigQuery storage or Cloud Storage or Cloud SQL. And we are still working on doing a POC using Big Lake. That is still in pipeline. But so far we are doing these and also analyzing the data on BigQuery. Currently, we are using Tableau for our dashboards, but we just came to know yesterday that BigQuery now supports Looker Pro, which is a merge of Data Studio and Looker. Previously, Looker was more like a marketplace deployment, but now Looker is something that is coming by default with BigQuery. So there is no Data Studio anymore, which is a good step towards unifying BigQuery and visualization in terms of scalability. And of course, as I said, just like you can query the data using storage API, you can trigger the jobs using different APIs as well. Currently, we're primarily using Python or PySpark to run our jobs on BigQuery. And we are doing the job execution as well in different ways, like triggering the jobs via Python. The data science team does that in a very regular way and deploy their code on Kubeflow. So because BigQuery supports all of these features, it made our life much easier in many ways. And one more request that we were actually asking yesterday as well for the Google team was, currently BigQuery doesn't show you the query plan. I think it only shows you how much data is being used and how much time does it take to compute. So it would be good to have such kind of a feature to understand how BigQuery will be running my query so that we can make those optimizations. But currently the query execution details, we can only see it after the query is run. And we can also track how much data is being consumed and how much cost has been incurred. And I think the amount of slots that you can use depends upon the plan that you are in. Say if your plan is on-demand scaling, then the slots get allocated to you based on the query load up to the limit. So say if your project has 2000 as a quota, you can use up to 2000 slots for your queries. And once the quota limit is reached, then your query abends, saying that the processing has stopped because of reaching the threshold. But so far, I think on BigQuery, pretty much the data engineers have very good experience on using BigQuery. We never faced issues with huge volumes of data yet. So here I'm just explaining like the high level, the BigQuery architecture, right? So of course it uses Dremel as its execution engine and Colossus as a distributed storage area. And between those two, there is a Jupyter network they're using for faster transfer of data across the compute and storage layer. And of course, we haven't really explored the streaming of the data to BigQuery directly. I believe we should be able to use that. Even the pub/sub topics, whatever we define, we can stream the data directly to BigQuery. But we haven't got a chance to test that yet. Coming to the BigQuery design, so currently GCP offers this level of hierarchy where for each organization folder, we have project folder, and each projects we have maintaining multiple data sets, which is synonymous to Teradata schemas that we maintain. And each dataset has multiple tables, views, routines created, and access can be provisioned at the table level or dataset level or project level based on the use case. And even the quotas were also allocated at the project level currently. So based on the usage, we can either request increase in the slots or change the pricing model from on demand to flat, right? But yeah, this is a high level design in GCP, like how data sets are created, how the tables are created, synonymous to on-prem, and we are using IAM permissions to limit each user having access to a specific data set that they are allowed to use, right? And coming to the storage copy, currently BigQuery it does data copy to different zones, but since we are creating a data set at the region, national level, like region level, US or Europe, the data gets copied to multiple places, multiple zones. But currently, we could not define like which region to copy to, but BigQuery does all of these things at the backend, right? And similar to Teradata, I think BigQuery also supports similar stored procedures, or you can define those UDFs as well, which we can define our own user-defined function and call it for any ETL purposes. And information schema is what BigQuery provides, where you can query the metadata on the data sets or tables to understand like what is the DDL structure of the table, and basically you can reuse it for other use cases. So we have seen BigQuery storage and BigQuery compute so far. Coming to for traditional OLAP, BigQuery for as an analytical tool. Of course, we already spoke about how scalable it is and how that is really beneficial for data engineers and resolve some of the bottlenecks that we see in on-prem. And of course, we have seen the high capacity storage. I don't think we have high-end storage on BigQuery. It might be in terms of petabytes, but at least for our use case, there is no need to request a DBA to increase the capacity storage for our schema. And BigQuery also supports time travel feature. So currently, there is something we don't have on Teradata. So someone deletes a table on Teradata sandbox. It can be a pain to retrieve the data back, but BigQuery by default, it supports 7 days of time travel feature enabled. So you can pull your data as what it is from the past 7 days. And also we can create our own table snapshots, which we can use if you want to have more number of days as a backup. Instead of relying on BigQuery time travel feature for 7 days, we can have our own frequency of snapshots so that you can always retrieve the data that is as is in the past few days. And the charging of BigQuery is done based on the compute, how many slots are using. But BigQuery also supports caching. So if you are running the same query that you have run before, the result is being retrieved from the cache, but it's not touching the actual tables. So that would save time and billing as well for the end user perspective. Coming to the other support, I know we talked about client libraries support and API calls. BigQuery also supports a traditional SQL dialect, which we use for multiple use cases on-prem. And we also talked about the federated queries and multi-statement transactions, which will be very useful when we are trying to run something, and if something happens, we want to roll back whatever that has run before. So the multi-statement transaction support is also available on BigQuery as of today. And we also talked about the BI tool support for BigQuery, like LookerML or Looker Pro is what we call, and also Tableau, which we are currently using as our BI tool. And for the API calls, as I mentioned, we can query BigQuery in multiple myriad ways. using Python, PySpark, or whatnot. And also we can use BigQuery as a sync tool to dump Stackdriver logs to BigQuery for any analysis if you want to do, or ecosystem using BigQuery as a storage. So from administration point of view, currently BigQuery encrypts all the data using Google managed keys. And those keys can be encrypted using customer managed encryption keys as well. Okay, I didn't see that. Are you intended to use Looker in the future? I think that's a discussion that needs to happen with our BI team. We have seen a preview of Looker, but we never got a chance to use it for our use case because I think it would be a bit, you need to have those skills to develop the dashboard. Like unlike Tableau, Looker is not business user friendly. It's more like creating those dynamic SQLs. You wrap those SQLs dynamically and create those dashboards. Whereas Tableau is purely drag drop. You don't need to understand the coding, but Looker, I think technically you need to have those skills. So we had the preview, but we will see based on the use case. If we really need a real-time reporting, we might end up using Looker because or Tableau Cloud for that use case.
It is real-time reporting the gotcha.
And
Previously, you
coming
are
to,
not able to.
Is there any other question or we're good?
Sorry, I'm not sure. Are you able to
Okay.
hear me or not?
You can.
Who is sharing?
You can take the chat.
Chat window.
Chat window is up. Yeah. So is the audio not coming up for Jonathan to hear?
You hear can hear your computer hear him?
No, I can't hear him as well. Or maybe it's
Yeah,
in
I
my
don't
laptop
think.
issue, I guess.
I don't think you can hear me.
But can Jonathan hear me?
Yeah,
Other people either.
You can hear.
He can hear us, but we just can't hear him. So I think I'm just using the chat window currently. I think we'll not be able to hear me.
Yeah.
Okay. Should I go ahead then? I think.
Yeah, I think he said go ahead.
Okay.
Go ahead.
Yeah.
Perfect. Yeah. And coming to the security point of view, because going to cloud security is one of the major area of concern. And I think Google does a good job there by default. I think GCP encrypts your data at rest and motion. And it also provides the ability for the customer to encrypt their data. They call it customer managed encryption keys, which can be used to encrypt the data, and Google rotates those keys, or we can have that control for us so that we can rotate those keys and encrypt the data with different keys. And all the authentication to GCP BigQuery happens either via cloud identity, which it can be a human account, which is controlled by user ID, AD group, or it can be a non-human account like service account, which they call it. So with using either of these two, we can access the data that is in BigQuery. This way, we are actually controlling like who can access the data, who cannot access the data, and we're also at least limiting the data leakage that can happen on BigQuery, and also provision a specific IAM control on the data. We can use either Terraform or GCP UI directly, or you can maintain your own list of permissions and trigger the set IAM policy using BigQuery APIs. So there are multiple ways to control the IAM permissions on the BigQuery data. And since BigQuery sits in GCP, there are many ways to audit who is tracking the data, who is using the data, who is retrieving the data. One way is to use cloud audit logs. So whatever table that you are accessing currently, it gets tracked on the Stackdriver. So you can retrieve those logs, query those, and see like which all users or service accounts are using this table and what are they doing with that table. So you can maintain that auditing activity so that if it's needed in the future for any audit reasons, we can showcase or we can trace back like who all deleted the data or who all accessed so and so data. Like for example, even ANBC has this feature enabled currently. Anyone who creates a table without a proper label gets deleted as soon as it's created. So all this is being done using cloud audit logs or BigQuery logs and cloud function. So that's one way you can track who is accessing the tables or who is inserting records or updating records. This would be useful for many use cases, or if you want to enforce any standards. I think currently NBC is already doing it. So I think this would be a helpful feature for anyone who wants to make sure all of the developers follow some guidelines. And coming to the governance piece, so as I mentioned, all the access is controlled by cloud IAM roles at different levels, project, dataset, and table levels. And BigQuery also supports authorized views. So authorized views is more like without granting end user access to the underlying table, you can directly grant access them to the authorized view. So the authorized view can access the data which sits in a different project or different data set. So this is really helpful feature because currently in Teradata, if someone has to access a view, they need to have access to the underlying table. Whereas in BigQuery, you can separate that out, which we are pretty much using it in multiple ways. Like for example, EDP, which is our enterprise data platform, it doesn't grant access for end users directly to the underlying tables. It creates this authorized views, and end user can access that authorized view for their reporting purposes. And even when we are sharing our data to business users, we don't need to really concerned about where this table exists. We just create this authorized views in the shared layer, and business users directly access those shared layer tables. And that's how some governance that we are bringing in, making sure that we are not worried about we are sharing any unauthorized tables. So this is done at the table level. And similarly, BigQuery also supports row level security controls. So currently, at least in CVS, we have client level restrictions. Only folks who have signed an NDA should be able to see specific client data. So instead of maintaining multiple views for each client, we can leverage BigQuery's row level access policies, where you can define data control language. You can define this record with this client can only be accessible by so-and-so AD group and so-and-so service account. So this can be automated as well using Python APIs. But yeah, BigQuery supports this row level security feature that is pretty much functional requirement for any companies like Caremark. And BigQuery also supports column level access control using policy tags. We haven't explored it yet, but I think BigQuery GCP is coming up with Dataplex, which is a data cataloging tool. It also supports column level encryption. So you define all PHI, PII fields or columns, the specific tag, and you can define what all we need to do with those columns, which has a specific tag. Either we have to mask it or encrypt it based on the end user permission or service account permission. So that is something that is already in place currently. We haven't got a chance to use it yet, but row level security is what we are currently using to restrict any unauthorized data access to clients. Oh, okay. Thanks, Jonathan. I'm not aware of that. So column level encryption, when you say column level encryption, is it using policy tags or is it more like
Policy type.
Policy
Data
tags?
catalog kind of policy type.
No, EDP has implemented is what Jonathan was mentioning. So I was just curious, is it being done manually, like maintaining a table separately and encrypting those columns, or is it more like you create a policy tag on top of?
I think he's talking
I
about
wish
the-
you can.
Oh, it's
I wish you
voltage.
can
Okay.
hear me.
Jonathan, is that what you are talking about?
Yes,
That's
That's
a
correct.
customizing.
That's a customized
What is that
implementation.
What is that coming? Voltage?
Yeah, voltage.
So,
Voltage.
yeah, we are using voltage for any sensitive data encryption
For masking?
for masking.
Oh.
It's not actually masking. Masking also we are doing it, but say like a member's birthday, right? If a specific AD group is not supposed to see member's
Kind of
birthday,
encrypting.
we are kind of adding a dummy value to it.
But that's kind of like a customized solution, not
Custom
not specifically for BigQuery. But it's a demonstration. BigQuery can interact with the UDF. Well, because of the way to implement it is you enable a UDF, a user-defined function inside BigQuery. And from there, you can invoke other things. You can invoke like a cloud function. You can invoke, you customize the code, and that's how it works. So that's not specifically a function for encryption in BigQuery, but it's more about in BigQuery you can use UDF connected to cloud function and then do a lot of functions. But
Right.
but I think the column encryption, the default setup in Google is the data catalog and the policy tag.
I think by default it's column encrypted, right?
Well, policy tag and the data catalog is kind of the default, right? It's a default solution.
Just one thing, like out of this equation, is it good to have encryption or masking when we talk about sensitive data? Those are different like terminologies.
Well, my
What is the recommended way?
my comments is it depends on what you are trying to do. Masking is supposed to be one way.
So when you mask the data, so behind the scene when you save the data and when you demask the data, right? So
No. You are talking about encryption, I think.
No. I'm talking about both the stuff. Like, is it good to have encryption or masking? When you
Well,
talk
these are two things. So in theory, masking is one way. So you mask it, you cannot reverse. If
Okay.
you can reverse, that's encryption. That's encryption and decryption. So if you want to mask it, it can mask on anything like a star. So nobody can
there
access
is
it.
nothing like unmasking.
No.
Well, if you can reverse it back, that's encryption.
Okay.
That's basically you encrypt it, and then you can encrypt it, like decrypt it back. So I think that depends on what you need to, right?
I'm not sure. Like, I have used the tool SnapLogic. So what happens really in that tool, like once you create a pipeline, so there is a masking task in between. So like just to avoid people seeing the logs, that the sensitive information log. So what they do, they mask the data, but eventually the correct data is being flowing to the user. So eventually, I believe like behind the scene, they are doing masking, unmasking, but in the log, they are putting the unmasked data.
Mhm.
So there should be I'm not sure about that one masking. Is there a concept of unmasking also similar to decryption?
I don't think there is a way to unmask, because to unmask it, you need to understand like what is the actual data, right?
So might be I'm saying that behind a user might be presented with the masked data, but behind the scene, unmasked data is saved. What does it mean? Suppose, for example, my name is Nishan. So you are masking my name XYZ, okay? So as a user, you will be presented with XYZ, but behind the scene in the DBMS, it is saved as Nishan.
I think the way EDP does it, what I have seen is what you mentioned, right? It's storing the actual data, But if you're not authorized to see it, it's going to give you the mask data.
I could not recall. There is something in Azure also that does the same stuff. I could not recall on top of my head,
Okay.
but there is something like that.
But this solution was more like custom made, but I don't know if BigQuery supports that column level masking that you're talking about. Here we're manually checking if the session user, if the member is part of a specific group, and then we are masking.
Because I feel like encryption and decryption might be more expensive rather than masking and masking. That's one thing. I don't know about unmasking, but masking is like you just put some regular expression and just mark the data, right?
Right. Yeah, that's a good point. Yeah, I agree.
But by the way, can Jonathan hear all of us or just hear you? I'm not sure if the audio worked in
I think he mentioned he can hear us, but I don't know.
Okay. But we cannot hear him.
Yeah, when Jonathan also mentioning that Voltage is also coming out with this encryption decryption feature with Google as a product offering. Yeah, Voltage is a product. I think it's HP product, I guess, that CVS is using for encrypting any sensitive data currently. It's an old service. Vault service. And I think we also have the BigQuery UDF now they have created. So where you can directly call the UDF.
Mostly, I think CVS, right? You see from Azure or AWS, use the native KMS or the key vault, but it is backed up by our CM keys.
Right.
We manage the keys and it's all converted to H7.
Right.
So we just hold the data key.
Right. I mean, even BigQuery has this KMS key concept, but CVS is using Voltage.
They don't trust even.
Right. Yeah. So
every provider providing like provider managed key system and your user managed.
No, they will give both. Either they manage for you,
but
they hold the data key,
they hold the
or they will actually give a methodology for you to create the key.
Create your own key for yourself. So yeah, so you can close the chat. Hearing is one way, encryption is hashing. Okay, I can see it. Yeah, that's right. Yeah. So masking is more like hashing, where so yeah, that's about the column level access control, and Dataplex also supports the data quality checks that you can define. Okay, it's format preserving as well. So encryption decryption is format preserving. Maybe hashing does it too, I guess. Okay, got it. Okay. Yeah, I think we are using hashing for one of our use cases as well. Like for the deduplication, we are doing this MD5 check. So every time we generate this MD5, run our call, each row is being passed as a string to MD5 function and getting the hash value of it. Okay. So that can be used for deduplication. If the same record comes into the database again, we are using the MD5 value to deduplicate the data. And coming to the data quality checks, Dataplex has this data quality checks feature that we can use to run any quality checks on BigQuery tables. Currently, we haven't explored it yet, but that's an offering that GCP is providing. And the data quality is an open source package that is available that GCP is using, customizing it and giving it to its customers. We haven't used that yet, but yeah, that is definitely available, which will be useful for data engineers to create their own rules and do their custom validations on specific BigQuery tables. And of course, there are a couple of features as well that we haven't explored yet, like using serverless Spark on BigQuery, or even all these use cases that we're talking about, like the big lake concept, where we can run our federated queries with storage being in different clouds, storage areas.
Have you tried to define your data quality rules centralized?
We haven't started that yet, but yeah, that is a good use case for doing any data quality checks. Yeah, BigQuery, the other use cases, some of them are being explored, but we haven't got a chance to use it. Like the BigQuery UDF, I think it's already in place for voltage encryption decryption. Previously, we were using a Dataproc jar solution, but now BigQuery, we can define a UDF that calls cloud function, and the cloud function runs its own job, either using Python or Java, and user return back to BigQuery. So all the cloud functions are accessible as a UDF in BigQuery. So that's a better way to access cloud functions using BigQuery. And some of these features are still in preview mode, like BigQuery search, where user can search a specific data and that scans across the table and gives you the matching records accordingly. And also BigQuery ML, which BigQuery currently supports creating your own linear logistic or any other regressions that we run, or any ML algorithms that we traditionally run in Python. We can do the same in BigQuery as well, using BigQuery ML.
Search is based on default syntax, right? It doesn't understand free text. Right?
The BigQuery search, I think it's free text one.
Is it free text?
Yeah, it's a free text. So I think that's what even Michael Eason was talking about, right? Something like you search something and you get all the data tables that match with the data. Similarly, BigQuery is in preview mode. We still didn't do it in live.
I thought even though they do free text, what's behind the scene
I think so. Yeah, probably. But usually BigQSQL, where we give it as column name, right?
Yeah.
But here we don't need to do it. You just don't need to understand the underlying schema of the table. You can just search for the word and you can find the matching table, matching records.
Is it similar to elation, like you can search anything?
Yeah.
Just search for data. You can search like table, column.
Elation will not query the data,
No,
right?
no, I'm not sure.
Okay.
Oh, you can query the data also?
BigQuery search is more like querying on the data. Like say you have a 5-6 tables with multiple columns. You don't need to understand like what columns exist. You can search for a specific field like Etna or PBM care.
It's doing the computation?
Yeah, it does the
So
computation.
then it's quite expensive.
It's quite expensive. That's what I'm curious about. Yeah.
It will be disabled what the company does. Because you never know what you're searching for.
Right. Yeah.
Elasticsearch now is gone.
That will be
Cloud
Right.
search is gone.
Right.
I mean, think of that way, right?
Right.
I was
Research
just thinking
is
like-
expensive.
I was
It's
thinking it
expensive,
will give the recommendations, like this is the table name or column name you're passing in, it will just.
See, it is completely an anti-pattern of what question you asked yesterday. Remember, if I actually put a query, if it is a bad query, right?
Hmm.
The amount how it takes, this is an opposite of
Yeah.
it.
Oh yeah, definitely. Yeah. I think these are other use cases, some of which we haven't explored yet, but that are available in preview as of now. And I think BigQuery is also coming up with sampling of the data.
I think they started supporting the iceberg formats.
Yeah.
Right? They started supporting iceberg formats. and
Oh yeah,
data,
right. Yeah.
a lot of
Yeah.
things, right?
Right.
now. It's not even previous.
Right. But it's good to have like all these features coming up onto BigQuery, like
Yeah, because adoption is there.
right. Yeah, definitely. Yeah, good for SQL developer. They can write their own ML. Johnson was mentioning that.
Actually, I got a question, related question, from the, one of the node. So, Spanner
Mhm.
is, basically it's a hybrid. It can handle transaction, also handle analytics.
Right.
And, it can provide a high availability and all of that.
Right.
So, but the BigQuery is a suggested tool for kind of like a data lake operation for data analytics. Is that the major difference only on price? Is the Spanner cost too much, or what's stopping why everybody using BigQuery for data analytics, not Spanner? Is that the cost?
No.
No, I
That's just
think-
one. I think
yeah.
the integration, out-of-box integration capabilities of BigQuery to support
Very good
various
point.
sources is the main driving factor. For
Mm,
support.
mm.
And the whole of management and orchestration makes simpler, right? You're not worrying about anything under the hood, right? No, all you're just looking at, that's the job.
And even Cloud SQL and Cloud Spanner are more like for
Yeah.
transaction
For,
systems.
yeah.
And
for-
Spanner has like very limited connections. Like
Hmm.
with BigQuery, you can have n number of connections outside the
Good
cloud.
point, yeah.
Any cloud provider on-prem you can connect, right? But I think Spanner has a limited.
But it
Yep, agree,
has
yeah.
a mechanism to
They might be growing.
utilize the connection pooling concept.
Yeah.
In an intelligent way. So it has its own advantage, but yeah, BigQuery is.
Well, the pooling one is one big issue of the spanner. It seems it's a key needed to be kind of like have to be like randomly sequence.
Something
randomized.
I've heard about that. That's why.
And if you have a sequential key, you got a really, really kind of, they call it a hotspot. It's got a huge performance problem. So
Mhm.
But I think you can define. The
You can-
pattern threshold and
Yeah,
you can
yeah.
stop it. There is
it's a
ways.
UUID.
Yeah.
Usually you have to
Right,
add a
right.
UUID to it, randomize it.
Mhm.
Otherwise, it's a total process on one.
But like I've seen like in office hours or most of the tenants are asking for Spanner as well.
That's
Like,
it.
yeah, for OLTP, yeah. In Cloud SQL and Cloud SQL, if you want in a scalable version, it's Spanner is what they're using.
I think the problem is really understanding the trade-off between usage. So I have one platform where I have multiple usage.
Hmm.
So how do you basically restrict those specs? Oh, okay, I have to go for this scenario. I go for Spanner versus, so now BigQuery has all the capabilities. This
Right.
is where, the whole cost comes into picture, right?
Right.
So it's very big.
I mean, it also
Trade-offs.
depends on the use case, right? If you're doing like 80% of reads and 20% of writes, like depends upon the read-write operations. If it is more significantly write operations, you go with OLTP systems like Spanner.
Application. I don't think anyone will go to BigQuery. They will always provision Spanner, right? Or SQL, some SQL server. Nobody will go to
I
BigQuery.
mean, at that time,
Just for
that point, it comes to the behavior of the application, what it actually does. Nobody will come all gigantic data files.
I'm not talking about
It's a normal use
Facebook
case.
web application. I'm just
Yeah,
talking about normal web
absolutely.
application. No one will go to BigQuery, right? It doesn't mean no matter it support OLTP or lab both, but no one will go to BigQuery. So that
Yeah.
those things are being handled by Spanner or like other SQL lines.
The specific tools, yeah.
So basically, there is a different use case. This is really out of the box. What we have done. So these landing zones of BigQuery from Google, right? So what they do basically, they don't want people to simply, get that console access. So what they do is they kind of, wire a web application with an SSO kind of thing, and they will actually track them to that landing page of BigQuery. You do whatever you want, but now the session is very much to context. In those cases, again, right? So it's very easy. Now we can actually simply plug in play, right? You don't have to build.
Right.
So now,
I think-
in one of the slides you mentioned about regional failover.
Right.
So BigQuery does not support regional
I think BigQuery supports it, but it's not visible to the end user where the data is being persisted to different regions.
So when you create a BigQuery like this host, right? So
Right.
you mention a particular region, right?
No, currently its region is US.
No,
Like,
it's not. I think it's a reason. Sir.
It's region specific, right?
I don't see any region option when I'm creating a data set.
I don't
No,
think.
no, no. So when you create BigQuery, I think it is region because obviously there's multi-AZ, etc.
Right.
But it's still a region source.
Region as in not in a traditional way, like only create this data set in Virginia.
So not like that.
Yeah.
Not like that. When you create a BigQuery, it is a region source, meaning it resides on that region based on OAZ. Now, if you wanted to access from West, you still have to create instance of BigQuery or take some snapshots and have that active kind of
If you write it as a US location.
Yeah,
US location,
US
then you do
location.
not have a problem.
Because currently,
Because it has backup.
yeah.
Replica.
No. So, okay, I can still limit that. For example, if I create a BigQuery, if I give, okay, these are the regions I'm actually targeting to versus I only care about USCs. Two different things. So is BigQuery doing it behind the scenes?
I
Without
think so.
your intervention? I don't think so.
I don't see any option to create data set in North Virginia or like any specific region.
It might be the case that service is not available in that particular region, but if I'm talking about the whole, when you create BigQuery, you should have the option to select this region or this region, right? it might be that there's like under the hood, they are creating the.
Right,
compute engine,
replication,
compute
yeah,
in those particular zones, right?
right. The replication is happening, but
And even if
currently,
it is happening across a region, they
Right,
should be mentioning somewhere, or they should have I'm not sure about GCP, but Azure, they already mentioned the documentation, like US East is paired with US West. So if any failover will happen for East, it will go to West.
I don't think,
Similarly, there should be something in GCP also.
right,
If
right.
This is paired with this region for any failover.
Yeah, we
By-
need to
by
check that,
default.
yeah.
If you are not putting explicitly, it should be by default.
Is there a major price difference to have a regional BigQuery or US like multi-regional BigQuery? I think the cost then is
That's what I'm
not.
asking, like when you create a BigQuery report, so you select you can select multi-region or only one region?
Well, you can see like US. I know all
Yeah,
of our.
CVS is using US.
You cannot.
Cost is definitely. Cost is definitely, you at least pay for the storage,
Yeah.
The replica.
okay?
But,
So-
but wait, you have a replica even on the same region. You have a replica
They
even,
have the replicate the same different zones.
yeah, it's on different zone.
Yeah.
But you still have a backup, a recovery, disaster recovery. The multi-region is never for your backup and disaster recovery. Because of the multi-region is really for the availability.
Availability.
So like if you in a different.
Availability is on,
No.
is with the zone
So-
only.
No, so this is what I was telling, right? So he's, this example, right? So this gives me right on the back and saying, okay, this. Because, see, when you talk about regions, right?
Uh-huh.
So it is like this, right?
join this one?
1, 2, 3, right? So now
Uh-huh.
what happens is, this is their data centers.
Uh-huh.
So it is, right? Now together it is the region.
Yes,
What they do is, they have all this replica set. If this goes down, you're still.
correct.
Because this is what HA. Now the DR, see, I can treat my HA and DR together. Either I can actually, because people are getting confused with HR and DR, right? DR is basically, when the region goes down, what do you do? What will you do? In that case, right? So now what happens is people will do multi-region. Right? So now-
Multi-region load balance.
R2, they will do, right? Different context. I wanted to basically have a active scenario. Whether I'm actually serving to a lot of global customers who's part from this. Now I want the traffic to route to west, people to west and east to east, right? Now this has a replication sync between those two. This is the perfect active VR sort of kind of thing. Today, what we do is all passive, meaning I'm actually syncing it and keeping a copy in the region, but I'm not actually using it, right? So that's the difference. So that's all active passive scenario. I don't really have to, because as your customers are all in USCs, right? They actually, they don't really see any kind of an latency or something. So that's the real difference between VR. But now you are paying for this. Yeah, it is like interpret.
Yeah.
Is there a
Not really, because you pay the difference. For like, well, even when you only have one region, right?
No, correct. That's
You
right.
still have to copy.
Right.
You
So,
pay,
this is right. So if you're using that just for reads, yeah, the cost is not in, correct. This based on whatever you say, but you're still paying storage.
Yes,
Whatever you
yes,
get,
right,
you're
right,
still paying
right.
for it, right? I think that's where the VR, I think, most of the scenario, you really don't have to make a VR. VR has become like a principle, right? I wanted to make sure I isolate my data within a geographic location.
Mhm.
I need to separate it. That's something written on stone, kind of. You don't even, they don't even use it all. This scenario makes more sense.
Yes,
because, you know,
performance point of view, that
yeah,
makes more
makes sense.
sense.
Very tough to basically get an active as well. Very tough. There's a lot of-
But I think BigQuery, when you define
Yes.
US as the region, I think it does the same as what you explained, I guess.
Well, usually all of our the BigQuery we have, all the data set is US based, is US location.
Yeah, definitely,
So-
because we are not serving outside.
US based.
No, no.
Mean
When we
that,
do-
you know, it is still its region, right? So
It's
now eastern-
multi-region.
It's
yeah,
multi-region.
east and west are two, I mean, if you even see latency between those, you will have a considerable latency. Because your network setup,
I think we do not have something like US as a region. They have US East, US West, these are the reasons.
No, we have, it's a US location, I think.
Right, yeah, I
It's a
think
US location.
So
when we
you
give
do
US location,
you
it
do
does.
BigQuery, right?
No, well, you can have a regional or you can have a US location as a multi-region. So then it will automatically select.
No, when you do US location, it's going to populate a list which all locations.
I do not think so.
You can- you
Why-
can-
Currently,
why
it
create-
doesn't show us like the option currently.
it?
Yeah,
That's strange, because I thought that there is.
you just give the
So it's a-
region.
What you are talking about is kind of a traditional way, even true on the GCS, but I do not think it's for.
GCS is global. You do not select the location at all.
No, GCS will give you,
GCS is regional.
is
It-
regional.
It's a regional, but within the region is automatically multi-zone.
Okay.
But
Yeah,
you
they,
can
they, I
select
think
the-
they keep a 3 copy of that, right?
I do not remember how many copy, but it could be multi-region, two region, called dual region, or multiple
Right,
region, or single region, regional. So there are 3 options, but for BigQuery it's not.
So for BigQuery, these are the listed regions that supports. So
Yeah.
whenever you give
Yeah, so if you
US,
see reason names like East 4, East 2, these are the reason names. See,
right,
it's
but
nothing like US.
Well,
yeah,
why-
the
why-
multi-region.
US is geography.
no, here if you see,
So,
yeah, the multi-region, when you give like US, it comes under multi-region.
correct.
So that's what I'm saying. Multi-region means like US selecting East A,
Uh,
East B, then it becomes multi-region.
But we don't control that, like BigQuery is doing that
No,
behind the
you
scenes.
you will try to create a new BigQuery.
You have the
It will give you the, it give you the.
Yeah, we
option.
can check offline. Like
Let
I
me
think-
stop sharing.
Yeah,
Maybe
you can
it's-
stop sharing.
Hey, thanks, Jonathan. I think Jonathan pinged something.
We'll try to add
Yeah, I think there is some price difference as well.
Absolutely.
Yep.
I think I'm free.
So if I create a new data set, I think,
And then because block is a roulette.
yeah, it says by default US is multi-region in US, but doesn't tell you where it is being replicated.
Yeah, see the option.
Oh, I am on
Yeah,
the screen.
I have it.
Okay.
So I do need to join another meeting. See, the US multi-region is an option.
Okay.
So you can,
Oh,
yes,
it
so
is one of the options. Okay.
Yeah.
Right.
I,
Right.
I do need to drop and then join another meeting, but great presentation. Thanks. Steve.
Hey, thanks. Yeah, I think we can do regional as well, but I think in CVS we are all doing multi-region.
They will specify those regions because they also needs to make sure there is a network setup in that region. It's a lot of other
Okay.
factors. I can't really do some, US Oregon side. I can't do that. We need network as well. So,
Yeah, I think
We do have the report.
even the cost estimate is showing like one region and US region, what is the price difference?
yeah.
You record it too? Maybe you have, you.
No, I haven't.
Well, why am I not covered? It's supposed to be you reported.
Yeah, I
So,
haven't.
It's a region to region cost, right?
Yeah.
I know it's-
I think
Did you? But what?
Yeah.
Did you report to the local? I want to make sure.